Your FastMCP server is ready, but how do you actually use it with Gemini CLI without manual configuration headaches? You'll see exactly how to install and register your server in one command, including automatic dependency handling and server object detection. The pattern even supports custom server names and project-specific configurations.
These are equivalent if your server object is named MCP. FastMCP, install Gemini CLI server. FastMCP, install Gemini CLI server. Hi, MCP. Use explicit object name if your server has a different name. FastMCP, install Gemini CLI server. Hi, custom server.
This demonstrates the command line integration pattern for seamless tool registration between local development environments and external systems. The pattern abstracts away the complexity of dependency management, environment configuration, and transport protocols, allowing developers to expose local Python tools to AI assistants or remote clients with a single command. What makes this distinctive is its focus on reducing friction between development and deployment, treating server registration as a first-class concern in the workflow. The approach works by encapsulating all deployment requirements, Python version, dependencies, environment variables, into a declarative installation command. Instead of manually configuring each component, the system infers defaults, like searching for a server object named MCP, while allowing explicit overrides when needed. This follows the principle of convention over configuration, where sensible defaults minimize boilerplate, but explicit control remains available for edge cases. The separation between tool definition, your Python code, and tool registration, the CLI command, keeps concerns cleanly divided. This pattern matters because it solves the last-mile problem of making local tools usable by external systems without operational overhead. It's particularly valuable for AI integrations, where developers need to expose functions to models like Gemini, but don't want to manage HTTP servers, API keys, or dependency conflicts manually. The trade-off is a slight abstraction layer, but the benefit, rapid iteration and deployment, outweighs the cost for most use cases. Use this when you need to bridge local development with external consumers, especially in AI-assisted workflows or microservice architectures. Let's break it down line by line.
These are equivalent if your server object is named MCP. FastMCP, install Gemini CLI server.
This installs the Gemini CLI plugin into your FastMCP server. When no explicit server name is provided, it defaults to looking for a server object named MCP in the target file, following FastMCP's convention for primary server instances.
FastMCP, install Gemini CLI server. Hi, MCP.
This explicitly targets the MCP server instance in server, pi for the Gemini CLI installation. The colon syntax disambiguates when multiple server objects exist in the same file, ensuring the tool installs to the correct instance. Use this pattern whenever you need to specify a non-default server name.
Use explicit object name if your server has a different name. FastMCP, install Gemini CLI server. Hi, custom server.
This explicitly targets a non-default server instance named myCustomServer in server, pi. Eliminates ambiguity when your server object isn't named MCP, ensuring the CLI installs to the correct instance. Follows FastMCP's file name, object name convention for direct object targeting. FastMCP server installation pattern. The file, pi object notation bridges Python's module system with FastMCP's server registry, enabling automatic discovery of server instances while maintaining explicit control when needed. Omitting the object name defaults to searching for MCP, server, or app, a convention that can silently fail if none exist. This dual-mode approach balances convention over configuration with explicit declaration when required.
The server that hides its name becomes the default for all names.